Hello and welcome to my YouTube channel. Today I'll be solving the last 30 questions of final year apply electricity 2024-2025 academic year. Now we start right away. We start from question 1. Question 1. Average mean value of sine wave is the average value measured over. So when you talk about the average mean, we measured over half a cycle. Because if we were to measure it over a complete cycle, you end up getting 0. You get the average mean to be 0. So as a result, we measured over half a cycle. Question 2. The following are the number of diodes which can be used for half or full wave rectification, right? So we can use, when it comes to what rectification, for example, for halfway rectification, we can use 1 diode. For full, we can use 2 or 4. So here, the answer is going to be what D, because here for half or full rectification, you can use 1, 2, or 4 diodes. So no 0 diode. The number of cycles in a second is called, that would be what, frequency, right? So then question 4. The root mean square value is known as effective value, right? Call it effective value. The root mean square is another name for the equivalent heat effect of AC and DC. So this is true, right? So when you talk about root mean square value, we are talking about the alternating voltage value that is going to produce the same amount as what? A DC voltage. So the answer here is true. How many diodes are required for half wave rectification? We need only one diode. So the answer is C. Question 7. For a supply voltage, then a supply voltage has a mean value of 120 volts. Determine its root mean square value. So to get this, the average value here, first, we have to get the maximum value, because we know that when it comes to root mean square voltage, right? VRMS, that will be equals to 0.70 times what? The maximum value. So I have to first get the maximum value. And since we are giving the average value, we know average voltage here will be equals to 0.637 times maximum value, right? So Vm, so I have to get Vm from this. And Vm here is going to be equals to, our mean value is 120. So I have 120 over what? 0.637. And what do I get? 120 divided by 0.637. So that will give me 188.38. Right? 188.38 volts. So that's the maximum. Now to get the root mean square value, that would just be what? 0.77 times the what? 1.38, right? So just multiply this by 0.707, and that will give us 1.33. So the answer here will be what? D. Now question 8. The process of obtaining unidirectional currents and voltages from alternating currents and voltage is called rectification, right? So the answer here is C. The current in an AC circuit at any time t second is given by I equals 120 sine into brackets 314.16 t plus 0.36 amps, right? So this current, find the time when the current is first a maximum. So here when we talk about phase maximum, that means we have to relate it to what? To the maximum current. The maximum current here is what? 120. So we are interested in the first time when this alternating current is maximum. That means when the what? The value of the current here becomes what? 120 volts. So I can do it this way. I can write that means 120 will be equals to what? 120 314.160 plus 10.3. So that means we are interested in this time, right? So when you do this, so here 120 will be divided by 120 here, right? You divide 120 by 120, so you get 1. Here, if we were to take the inverse of what? Sine inverse of 1, because we have sine here. Okay, I didn't bring the sine. There should be a sine here. So sine 314.160 plus. So we have plus 0.36, right? So here you take sine inverse of 1. If your calculator is in degree, you get what the answer in degree. So if you take sine inverse of 1 and your calculator is in degree, you see that you get 90 degrees, right? But you have to convert this to radians, right? So if you get 90, you convert it to radians, you get what? Pi over 2, right? So you have here pi over 2. But if your calculator is already in radians and you take sine inverse of 1, you just get what? Pi over 2 straightforward. So we get here 314.160 plus what? 0.36. So you see that t, which is the time we are interested in, will be equals to pi over 2 minus 0.36 all over what? This just 314.16. So here, what do we get for this? So I'll just here pi over 2. We have pi over 2. 2, right? Then minus 0.36. So we have this divided by 314.16. So we get 1.56, 1.57. Okay, let's see. So here, I think there is a mistake here. Let me do this again and see. Probably there's a mistake here on how I did it. So let me do this. So we have pi over 2 pi. Okay, pi divided by 2. So I'll get this, right? Okay, let me put this in brackets. Okay, let's have this pi. Then minus 0.36. So we get this, right? Then let me put brackets here. Brackets here. Then the whole of this divided by 314.16. So that will give us 0.3, right? 0.03. So we get this t equals 0.00385. 854. Right, seconds. So we change this to what? Milli. That is going to what? 3.85 milli. So the answer here is B. Now moving forward, question 10. A sinusoidal current has a peak value of 40 amps and a frequency of 60 Hz. At time t, okay, let me clean this part. At time t, meaning t0, the current is 0. Express the instantaneous current I in the form I is equals to maximum current times sine omega t. So how do we do this? Now, so you can see that if you look at the alternating current here, if we are to express in this form, meaning we have to find maximum current, then angular velocity, and that will be it, right? So to find the maximum current, we are already been given the peak value. The peak value is just the same as the maximum current, right? So we know that. Now the main thing, the next thing is just to find angular velocity. And you can see we are given the frequency. So we know that angular velocity is what? 2 pi times the what? Frequency. So I can write here 2 pi times what? Frequency is 60. So we get 120 pi. So, and we have been told that at time t0, then the current is 0. I mean, there's no phase angle. So the phase angle is 0. That means I can write this as what? The maximum current, which is 40, sine angular velocity, which is 120 pi t, right? So this is how we get. So this corresponds to which one? 120. So we have 40. We have 40, 120 pi. Okay, so the answer is this one, B. Okay. After rectification, the signal is being smoothed, right? So so this is true. Once after rectification, what you do is that you try to what? Sharpen the curve, right? Of the rectified signal. And you do that by smoothing the rectified signal by using capacitors, right? So the answer is A. Which of the following can measure an alternating current? So when we are dealing with current, to measure current, we need what? An ammeter, right? So here, since this is about current, we can use an ammeter. So the answer here is what? C. Now we go to question 13. So from question 13 to 15, we'll be using this preamble. Preamble 1. Use the instantaneous value of voltage in an AC circuit at any time seconds given below to answer question 13 to 19. So we have to use this to answer from question 13 to 19. Starting with the first question, 13. Find the peak value. So peak value is the same as the maximum value. So that means Vp is the same as Vm, which is here 200 volts. So the answer here is 200, which is D. Calculate the peak to peak value. We know peak to peak value is twice the maximum value, which is twice the peak value. So that will be 2 times what? 200. That gives us what? 400. So the answer is A. Question 15. Determine the frequency. To find frequency, we know angular velocity equals to 2 pi f. So if we make frequency the subject, we get angular velocity over 2 pi. So we have angular velocity from here is equals to 125.66 divided by 2 pi. So if we do this, what do we get? So we get 125.66 divided by 2 times pi. So we get 19.99. So that is just 20 hertz. So the answer here is A, 20 hertz. Now question 16. Find the periodic time. So once we know frequency, we know periodic time. So here will be 20 hertz. Once we know frequency, periodic time is what? 1 over frequency, meaning 1 over 20, right? So we take 1 divided by 20, meaning 20 inverse, right? There's a 20 inverse. That's 0.05, which is what? That will be what? 50 milliseconds. So the answer here is what? B. So here get 0.05 seconds. That is 50 milli. Calculate the angular velocity. So the angular velocity is already here, which is 1. So this one is here. The angular velocity is what? 125.66. So 125.66. So this is B. Question 18. Determine the mean voltage value. So mean voltage, I wrote this formula earlier, which is the average voltage equals to 0.637 times the maximum voltage. And that is just going to be 0.637 times the maximum voltage here. You can see it's 200, meaning times 200. And that gives us 1.274 volts. So the answer here is going to be D. Question 19. Find the phase angle in degrees. So when you come to the phase angle, you can see it's here, right? And how do we know this is a phase angle? Because we can compare it with the general expression, which is right this way. Angular velocity plus or minus phase angle. So you can see that this corresponds to the phase angle, and phase angle is minus 0.4. Remember, this is in radians. So we are interested in the value being in degrees. So we do conversion, right? So to do the conversion, I can write 360 degrees. We know 360 degrees equals to 2 pi. That means if we have what? Pi meaning that's in radians. So if I have now minus 0.4, I want x, meaning that is in degree. So we cross multiply. That means we have what? Minus 0.4 times 360. Then you divide this by 2 pi. So you get minus 22. So when you do this, so plus minus 22.91. So that will be 92 degrees. So we come here, that is going to be A. Now question 20. So here, when we talk about form factor, right? The form factor is going to be equals to, right? So this one, form factor. So I think that will go into 1.4. So we have peak factor and form factor. Okay. When it comes to a form factor, that is going to be equals to the next question 20. The form factor for a sine wave is, so when it comes to form factor, right? What we do is that form factor is equals to, meaning if we were to take the root mean square value. So in here, right, we are thinking in terms of, let's say we are dealing with voltage, right? Alternating voltage. So we have the root mean square voltage will be over what? Over the average value, meaning the average voltage. Average voltage. So with this, I can write the form factor as being equals to root mean square value. We can express in terms of the maximum value. That was 0.707 times maximum value, all over 0.637 times again maximum value, or there's the average value. So you see the maximum will cancel. So we just have what? 0.707 divided by 0.637. And when you do that, you get the answer to be 1.109. So that's just 1.11. So the answer here is going to be equals to B. Okay. The peak value of a sine wave is 200 volts. Its effective value is, so again, effective value is the same as root mean square value. So that means here, we just want the root mean square value. That is VRMS is equals 0.707 times the maximum value. That maximum value is giving us what? 200. So we just have the root mean square value equals to 0.707 times 200. That gives us 1.14. 1.148. Yeah, 141.4 volts. Right? And that would be question B. That is going to answer here for question, sorry. The answer for question 21 here is going to what? B. We get here to be B. How many cycles would an AC signal make in 2 seconds if its frequency is 100 Hz? So here, we know that frequency, when it comes to what? Frequency is simple, the number of cycles. Number of cycles over what? Time. Right? So here the frequency is given to you because the frequency value is given as 100. So we are entering the number of cycles, right? How many cycles? So we make the number of cycles the subject. So we get this. So this is going to be equal to frequency times time. And the frequency here is what? 100. So 100 times time, which is 2. So that equals what? 200. So here frequency with 200 Hz, right? 200. So the answer here is D. So moving on to the next question. We have question 23. In purely resistive AC circuit, the current through the resistor is not in phase with the voltage across the resistor. This is false because we know that if you are doing a purely resistive AC circuit, the current and the voltage are in phase because they have a phase angle of 0 degrees. So this is false. So A. For purely capacitive AC circuit, the current has a phase angle of, right? So here, when you're dealing with a purely capacitive AC circuit, we know the current leads the voltage by 90 degrees. So this is what, in terms of the current, right? This is going to be positive. So here the answer we want 90 degrees. So that is A. So if you are leading is positive, right? So the current leads the voltage, right, by a phase angle of what? 90 degrees. So that's when the current has a phase angle. So that's what this is about. Question 25. In an AC circuit, the relationship between the voltages and the currents can better be represented by a phasor diagram, right? So we have D. So the phasor diagram is used to illustrate the relationship between two or more sine waves. So that's why we use a phasor diagram in chapter 10 to show the relation between the current passing through resistors or through element and the voltage across the element. Question 26. A supply of 240 volts, 60 Hz connected across a pure inductance and the resulting current is 1.2 amps. Calculate the inductance of the coil. So here, when we talk about pure inductance, we are talking about purely inductive AC circuit. What that simply means that you have an alternating voltage being connected to an inductor, right? So only this is what we call a purely inductive AC circuit. That's a pure inductance. That's what they mean here. So if you want the inductance we know that the reactance of the inductor here, which is the same as the resistance, to the is alternating voltage, SL is equals to 1. Angular resistance, what the inductance. And then we know here, angular velocity is what 2 pi f, then mean times the inductance. So you can see here, if we are interested in inductance, so if I make inductance here, the subject we get reactance over 2 pi f, right? But here I don't know the reactance here. So how do I calculate for reactance and replace it in the formula? We also know the formula for reactance, which is inductive reactance, can also be equals to what? The root mean square voltage over what? The current, root mean square. So 240 here represent the effective value or the root mean square value. And the current here will also represent the what? The root mean square current or the effective current. So I'm going to have this to be equals to 240 divided by 1.2. And this is going to give us, what do I get here? 240 divided by 1.2. That gives us 200 volts. Ohms rather. This is what? Reactance. So that is 200 ohms. Now I can come here. That means 200 over 2 pi times frequency. Frequency is given the equation as 60. So we have this. So we have 200 divided by this. And I have here to be 2 pi times 60. So here I have 0.52. Okay, let me do this again. 200 divided by 2 times pi times 60. So we get 0.523. So that is 0.523 henries. So when we come here, question 26 is going to be what? This one, C. Okay, go to question 27, right? Moving on to question 27. Here, a coil of resistance 300 ohms and inductance 0.20 henries is connected to a 75 volts 400 hertz supply. Calculate the power dissipated in the coil, right? So here, when you talk about power dissipated, we are talking about the what? Meaning the resistor, right? Meaning the power dissipated by the resistor, right? And the resistor there, that is, we have here is the resistance here is what? 300 resistor. Its resistance is 300 ohms, right? We have this to be 300 ohms. So if I know the what, right? So we have this, right? So power will be equals to what? That means the current passing through the what? The resistor times what? Its voltage, right? And then here, if you look at this, you can clearly see that for this, since we are having an inductor, so we have to add what? Right? Cos what? Cos of the phase angle, right? So we have this formula here. This will be the power dissipated, right, in the coil. So with this, I have to get the voltage, right? Okay. So to get this formula, right? So that means that I have to first get the current passing through the what? The resistor. So how do I get the current? We can get the current by what? Using this formula, right? I know the voltage is given. The voltage is 75. And then we are given the what? When it comes to the uh, inductor, we are giving it resistance. So I can calculate the reactance of the what? Inductor. SL is equals to what? We are also given the frequency, meaning omega, which is just 2 pi f times the inductor. The inductor. So this will give us 2 pi times frequency 400 times the inductor, which is 0.2. So I'm going to get this part to be equals to, right? 0, meaning just 400 times 0.2. That gives me 80. So 80 times 2 will give us 160. So 160 pi, right, ohms. Okay. And meaning that is 160 times what? Pi. So let me just, we get 502.66 ohms, right? So we get this value. So to get this, because I want to find the current first before I can use it, I can calculate for the what? The power dissipated by the what? The resistor. So to get the what? The current, I know that the voltage supply times the current, meaning times the what? Impedance will give me the voltage supply. I mean current supply times impedance is giving the voltage. So to get impedance, now we use what? The impedance triangle. For impedance triangle for an inductor and a resistor in series, we get something like this. I can use this one here. I have the phase angle here. Here we what? SL, we have R and then Z. So meaning the impedance here will be equals to, using Pythagoras theorem, that will be what? Z square means square root of what? SL square plus R square. And that means I'm just going to have this. The resistance is what? 300. So meaning 300. So I can write 5002.6 square plus 300 square. Then square root of that is 50.2.6 square plus 300 square. So that will give me this, and the square root of this. It's not letting me okay, you take square root of what? 300 square plus 502.6 square. So you get 580, right? 585.32 ohms, right? So with this, I can now get the current. Current here will be equals to, because the voltage is 75, so 75 divided by impedance, which is 585.32. And that is going to give me, so 75 divided by 585.32. That gives me 0.12, right? So you have 0.128 ohms. So that is the current. So once I know the current, right, then I can calculate the what? The power dissipated, right? So mean power dissipated by the resistor is just going to be equals to, okay, is going to be equals to all of this, right? Meaning current, right? Current here is 0.128 times 75 times what? Cos, right? Cos of this cos of this. And what do I get here? So when you come to a cos of the face angle, cos of this face angle, right? Okay, let's do this. This times 75. Okay. So when we do this switch question, okay. So we have this, we have to get what? This and this is equals to what? Cos of the face angle. That is going to give us, if you look here, cos will be what? R over what? Z, right? So the resistance, which is what? Resistance is 300 over Z is 585. 585.32 ohms. So if you divide this, what do I get? Okay. Since I'm entering to next place, so I can clean this so that it doesn't interfere with this. Okay, let me write this clearly. So this will just be equals to, or I can just even write it here, right? So it equals 0.128 times 75 times now. Resistance is 300 over what? 585.132. So that we can have it this way. 0.128 times 75 times 300, then divided by 585.32. So that'll be 4 point, right? So that'll be 4.9 right here. Okay, let me go 4.92, right? So the answer here, when you do this, you get 4.92. So you can see we have 4.925. So the answer here will be what? A. Okay. So here we've gotten the answer. This one is kind of complex, right? Compared to all the other ones. Since so far, this is the hardest question, right? So we go to question 28. An alternating voltage V equals 250 sine 800 T volt is applied across a series circuit containing 20 ohms and 50 microfarad capacity. Calculate the current flowing in the circuit. So with this one, again, this time is similar to what we just did, but this one, they are just interested in the current, right? So with this, again, we want the current. So to get the current, again, we can use this formula. The voltage, supply voltage equals current times the what? Then supply current times impedance. And to get impedance, again, here we use the impedance triangle. So here is just similar to the other one we did. So here we rather have XC, and the resistance, we have the Z, the impedance. So you can see that I'm giving what? The resistance, then 11 now, the capacitive reactance. And here is what? 1 over angular velocity times the capacitance. So I have 1 here. And with this, you can see that the angular velocity is given here, which is 800, right? So I'll just take 800 times the capacitor, which is 50 micro, right? So this is just 50 micro. 50 times 10 to the minus 6. And what do I get? So if this is micro, this 3 3 of this will cancel with 3. So I have 10 to the power minus 3 here. Then 8 times 5, that is 40, right? Okay. So 40, so this will also cancel one of this. So we get here to 10 to the power minus 2. So I just have, you bring this up, what do we get? So that will give us 10 to the power 10. 8 positive, meaning 10 to the power 2 rather. 1 over 4 is just what, 0.5, right? 1 divided by 4, 0.25. So that means 0.25 times 100, that will give us 25, right? Times 100, that gives us 25. So this will be 25 ohms. So once I know this, I can get the impedance. We know that impedance, the same formula equals what? Square root of what? R square plus what? XC square, meaning the capacitive reactance square. So I now have this to be, and resistance is giving us what? 20. So 20 square plus 25 square, then square root of that. So that will give me the impedance. So we have this to be 25 square plus resistance is what? 20 square. So that gives us 32. So 32 point, you can say 32.02 ohms. So with this, I can now get the current, right? So make current the subject here. Current will be equals to voltage supply over what? Impedance, which is 32 point. Now to get the voltage supply, you can see that we are giving the what? You have an alternating voltage. So the voltage supply here, which is the root mean square value or the effective voltage in that context, it's just going to be equals to what? Right? That is just going to be equals to, so that is just going to be equals to, right? So this is a root mean square value, which is effective with equals what? In terms of the maximum of this was 0.70 times the maximum value, which is 250, all over what? 32. So we get the answer here to be equals to 0.70 times 250. And you divide this by 32.002. So you get 5.52 ohms. So the answer here is going to be what? C. Right? So we get the answer here to be C. And moving forward, we look at question 29. So with question 29, a 20 ohms resistor is connected in parallel with what? An inductance of 2.387 milliamps across a 60 volts 1 kilohertz supply. Calculate the supply current. So here, when it comes to this question, again, so you can see that when you talk about series connection, right, of elements to an alternating voltage, we have what? A voltage triangle. So since this is what now the elements have been connected in parallel, we have what you call current triangle. So to get this current triangle, what that means that I know here we have what? We have a resistor, right? So I'll sketch the phasor diagram. So the phasor diagram will look like this. We have VR, and then its current are in phase. So we have here to be IR. And when it comes to the what? The capacitor, we know the capacitor, the current leads the what? The voltage, right? So I can have current here. So it was the current here, IL, and the voltage, which is the same as the voltage across the what? The resistor, because they are in parallel. So the voltage is common. So we can sketch this. So we have something like, and here we represent the diagonal, represent the one, the current supply. So that means I can write current, which is the current supply, which we are interested in, because I square equals what? IL square plus what? IR square. So how do I get the current and then the what? This. So when it comes to the current passing through the what? Resistor, meaning IR, we can get it because we know the voltage supply. Because they are connected in parallel, meaning the voltage supply is the same as the voltage across the capacitor. So let me see here, which is the same as, inductor rather, keeping, this is inductor, not a capacitor. Oops. So this is what? VL. So we have VL here. It's the same as the voltage across the resistor, right? So with this, so if the voltage is the same, that means if I want to find the voltage, the current passing through the what? The resistor, it will just what? The voltage across over its resistor. So, and we know this to be what? So here the voltage supply is the same as the voltage across the resistor. So we have 60 over the resistance. What is the resistance? The resistance here is 20. So you see this will cancel. We have 3 amps, right? Then we can get the same for what? IL. So it will just be what? VL over what? Its reactance, that is XL. So with this, I have to calculate the reactance, right? We know this is going to be equals to what? Angular velocity times what? Inductance. And that is going to be equals to 2 pi F times the inductance. So this will be equals to 2 times pi times here the frequency is 1 kilo. 1 kilohertz meaning 1000, right? Times 1000 times what? So let me erase this part. Times the inductance, and the inductance here is milli, right? So 2.387 milli, that is 10 to the power minus. So you see that this will cancel what? The zeros here. So it's like we are just having 2 pi times 2.387. So we have 2 pi times 2.387, right? And that will give us 14.997. And that's just 15, right? We make it 15 ohms. So we have 15 ohms. Now that we have this, I can take the voltage across the inductor, which is the same as the voltage supply, and that is 60. So 60 over what? 60 over 15 will give me 4, right? So give me 4. 60 divided by 1.5. 16 divided by. So that will give me 4 amps. So once I have 4 amps, so I can come to the formula which I wrote here. We're interested in the current supply, right? So that means the current supply, using Pythagoras here, which we already done. So I will be equals to what? IR square plus what? IL square. And we've done this, right? IL is what? 3 amps. So 3 square plus what? 4 square. I think this will give you 5, but let me just do it. So we have 16 plus 4 square. 16, that is 4 square plus 3 square, which is 9. 4 square. I think this will give you 5, but let me just do it. So we have 16 plus 4 square. 16, that is 4 square plus 3 square, which is 9. So you get 25. So answer here should be equals to 5. So that is for question 29. Right? I have question 29. let's look at the last question, question 30. So with question 30, right? Question 30. Question 30. A pure inductance of 150 millihenries is connected in parallel with a 40 microfarad capacitor across a 50 variable frequency supply. Term the resonance of the circuit. So you can see here we are having what? A 150 Henry is connected in parallel with what? This, right? And the capacitor. Okay. So with this question, right? I think something is missing here. There should be right? So here the resistance is missing. So if the resistance of the mean is 0, right? So if this is 0, that means the frequency this thing becomes the resonant frequency for parallel resonant frequency becomes the same as what for series frequency, which means that, and the formula is what? 1 over 2 pi. Let's try this. 1 over 2 pi over LC, right? So if you have this 1 over 2 pi times mean times square root of what? The inductance is 150 milli. And then when it comes to the capacitance, 40 micro, meaning 40 times 10 to the power minus 3. So you can see inside this, okay, so times 2. Mm, 0.523. So if you have 0.0154, so we take inverse of this 0.01554 inverse, you get 64.9. So the answer here will be what? C. Wow. So when you do this inverse of this, you get 64.93. So that's just like 95. So the answer here will be C. Okay. So we've come to the end of what? The solution for last year's final year examination on applied electricity. Make sure you share this video with your friends and your colleagues so that they can also learn something from this. So I will try and then solve. You can see I also try and solve a final year examination on applied electricity for 2022-2023 academic year. I'll try and see if I have time to do that. Okay. See you in the next video. Bye-bye.